Hello all, my name is Khurram. In the previous video, we have already seen how feed-forward network works. In this specific video, we will try to understand what is backward propagation and how it works. To understand this, let me share my computer screen. Here you can see the representational diagram of artificial neural network. Here we have three layers: input layer, hidden layer, and output layer. To input layer, we pass the data as an input. In the last video, we have already discussed the input values was x1, x2, x3, x4. Then we have some kind of weight in this region, say w1, w2, w3. Then these weights are multiplied by each input, and after the multiplication, the sum of all the values are sent to the hidden layer. Hidden layer tries to find out the relationship between the data, and it tries to normalize the data. And who is doing all this? The activation function is doing all these operations. After these operations, hidden layer sends us or gives us some kind of input. That input is called y hat, and the difference between y and y hat is called loss. The overall objective is here to reduce the loss, because if we reduce the value of loss, then we'll get the actual output very closer to the predicted output. It means our neural network is working fine. So to reduce the loss, we try to use one concept over here, that is called backward propagation. Backward propagation. In backward propagation, we try to change the values of weights. So formula used for changing the values of weights here is, the new weight can be obtained by this formula: w new weights equal to old weight minus eta. Eta stands for learning rate, and derivative of loss with respect to derivative of old weight. This formula is responsible to change the values of what? Change the values of weights. So in the process of backward propagation, we implement this formula and we try to change the values of weights. After changing the values of weight, then feed forward propagation is happened, and we get another value of y hat or predicted y. Then we find out again the loss. If loss is reduced, then we perform another backward propagation. So in 4 to 5 epochs, so means one epoch is equal to 1 times forward propagation and 1 time backward propagation, that is equal to 1 epoch. So for every epoch, we try to reduce the value of loss, and we try to make y, that is actual output, equivalent to predicted output. In backward propagation, what kind of formula we are using? Weight new is equal to old weight minus eta. Eta is nothing but over here learning rate. Then we'll take the derivative of loss function with respect to old weights. So this is all about backward propagation. In the next video, we will see how this neural network is actually implemented using Python code. So see you in next video.